Okay, so for implicit differentiation, we're going to find the derivative of y with respect to x. So anything that has the x, we differentiate like normal. I'm going to differentiate y, but anytime I take the derivative of y, I need a dy dx. And then the derivative of 10 is 0. So now isolating dy dx, I'm going to subtract the 16x to the other side and divide by 2y. And we can reduce that to negative 8x over y. Now for b, I'm going to change these to an exponent of 1/2. So now finding the derivative, that's 1/2 x to the negative 1/2 plus 1/2 y to the negative 1/2 dy dx equals 0. I'm going to clean this up. This is 1 over 2 root x plus 1 over 2 root y dy dx. I'm going to subtract this to the other side. And then multiply both sides by 2 root y so that these cancel. So my final answer is negative root y over root x, because these 2's will cancel each other out. Now for c, I need the product rule here. So each piece, the derivative of negative x is negative 1. The derivative of y is dy dx. So first, the derivative of 5x squared. Now for the product rule, it's negative x times dy dx plus negative 1 times y. And then the derivative of 4y squared. I'm going to move everything that doesn't have a dy dx to the other side. And I'm going to factor out the dy dx from the remaining pieces. And then we can divide by the negative x minus 8y. This double negative in the bottom, if you want, you can factor out a negative from both the numerator and denominator. That's what we've done on the answer key. So by factoring out the negative, now I can make it positive of 10x minus y over x plus 8y. And then lastly for d, again we need the product rule for x and cosine y. The derivative of x is 1. The derivative of cosine y is negative sine y times dy dx. So finding the derivative of y squared, and then the product rule, I'm going to move all my dy dx's to the same side. Then factor out my dy dx. And I'm left with 2y plus x sine y. So then isolating my dy dx, I have cosine of y divided by 2y plus x sine y.